In this video, we are going to talk about another kind of loop. We're going to talk about the do loop and see how it differs from the while loop. We're also going to talk about two special statements that are used almost exclusively in loops called break and continue. And we're also going to see what happens when we nest loops. We saw previously that you can put if statements inside if statements. Well, you can also put loops inside loops, and we'll see what happens when we do. So let's start by taking a look at the do loop and compare it to the while loop. So let's just compare these two pieces of code, right? So this is one that we've seen before. We have a number. I'm going to call it number while. We'll say that it's equal to 1. While it is less than 10, we will write out the number, and then we will increase the number by 1. And so clearly what's going to happen is it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. At that point, it's going to become 10. It's no longer going to be less than 10, and we will break out of the loop. Right? Now, compare that to this thing. Right? Well, we have a variable, number do. We have a do loop, which looks very similar to a while loop, except for the fact that the while is at the end and not at the beginning. So we say do, then we have the body of the loop, check the number, increment it, and then we check to see is it less than 10. What's the difference between these two things? If we actually run them, right? What happens is this guy goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and then breaks out. And this guy goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, this guy's 10 now. We just incremented it from 9 to 10. We break out, and let's take a look at our output. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. These appear to be exactly the same. So why is it that there are two different syntaxes for what appears to be the same thing? Well, the difference is when the condition is checked. The while loop checks the condition. If the condition is true, it enters the body. The body is then executed. The condition is then checked again. If the condition is true, it enters the body. Otherwise, if it's false, it drops out of the loop. The do loop is subtly different. It executes the body, then it checks the condition. Right? If the condition is true, then it executes the body again, then it checks the condition. If the condition is false, then it drops out of the loop. Those seem to be very similar. What's actually the difference between them? Well, let's take a look at the strange situation where the condition is never met. Suppose I make a variable. We'll call it max, right, for maximum, and then we'll reuse our previously existing variable number while. We'll say that it's equal to 1. We'll say that max is 1. While number while is less than max, we'll execute the loop. Is it ever the case that 1 is going to be less than 1? No. So we are not going to execute the loop. If you compare that to the do, right, if we say number do is equal to 1, we are going to execute the body of the loop before we check the condition. Right? Now this may seem odd, right? It's not that common, you would think, that you would want to execute a loop where the condition was going to be false the very first time, and therefore in a while loop you wouldn't execute the body at all, and in a do loop you would execute it exactly once. But this does come up occasionally, and we will see examples of this in later videos where there are some relatively common situations in which you might want to execute the body and in which the condition may end up being false. Now, that said, these are relatively rare. I see while and for loops probably 100 to 1 for every do while loop that I see. One kind of funny thing that you might want to watch out for is it's possible to write do while condition, say number while is less than max. This is not realistic code. This is kind of funny code, but occasionally somebody asks me this as a programming puzzle. They will say, oh, did you know that it's legal to put a while immediately after the do and have a do with two whiles, right? And it's quite funny what this actually does. This do has a body, right? Well, while is a statement, right? So this is the statement of the do. And then this is the while that is associated with the do. Never write code like this. It is super confusing. But if somebody asks you that puzzle, now you know what's going on. Right. So that's the do-while loop. All right. So I also said that I was going to talk about the break and continue. So here's a common workflow. All right. You might have a loop that tries to do something. Did it succeed doing it? Great, then we're done. Otherwise, maybe you figure out, oh, it didn't succeed because I have some problem. I know how to fix the problem, right? So then we loop back around, try to do the thing again, right? Did we succeed? Then we're done. Otherwise, attempt to fix the problem. Keep on doing this. Well, how would you write this kind of workflow as a loop? Because it doesn't seem to exactly fit either the do or the while pattern, right? So this is just pseudocode. This code won't actually run here. But one way you could do it is you could say, well, I'm going to start by making a variable called succeeded. I'll make it a Boolean. And then the while takes a Boolean, right? It doesn't have to take a comparison to an integer the way we've seen every time. It just takes some expression which is Boolean. So we'll say, while we have not succeeded, then we'll say, well, success is equal to, did we succeed in doing something, right? If we did not succeed, then we try to fix it, right? If we did succeed, well, what happens? Well, we fall out the bottom of the loop. We check to see, is succeeded false? Is not succeeded true, right? If we succeeded, then we would fall out of the loop, right? Otherwise, we would enter it again. We would try to do the thing again. If we didn't succeed, then we would try to fix it, and so on. So this would be one way to write this logic, and that would be a perfectly acceptable way to write it. But another very common way to write this logic would be like this. So we say while true, right? Now, immediately you should be thinking, while true, isn't that going to loop forever, right? Clearly, this takes a Boolean that checks to see if the Boolean is true. The Boolean true is always going to be true, right? So we have to have some other way to break out of this loop in order for it to be not an infinite loop, right? So we would then say, well, we have our Boolean here, succeeded. You notice that the Boolean is now declared inside the body of the loop. We tried to do something. Did we succeed? Then we break. And the break means execute the loop immediately. Immediately just go to here. We're done. We are not going to check the condition anymore. Now, if we did not do that, then we try to fix it, right? OK, well, what happens if we do try to fix it? Well, then we loop back around. We check to see if true is true. It is. And then we try to do it again, and so on. So this is a very common way to use the break statement. So I've used the expression to break out of a loop several times. And in case that was not 100% clear, what I mean by break out of a loop is we want to stop executing the body of the loop immediately, just go on to whatever the next thing was after the loop, and not check the loop condition again. Now, we can also continue a loop. And to continue a loop is also to stop executing the body of the loop. Unlike breaking out of the loop, when you continue, the loop condition is checked again, and the body starts again if the condition is true. So essentially, break means skip the rest of the loop body and don't check the condition again. Just keep on going. And continue means skip the rest of the loop body, check the condition again, and then if the condition is true, enter the body of the loop. So let's take a look at an example of that. So for example, we might have a for loop. And something I didn't mention was the break and continue statements work in any of the loop constructs in C#. They work in while, do, for, and the other loop construct, which we haven't discussed yet, which is for each. All right, so here we have an example of not using continue. Right? So we have a for loop. We declare our loop variable number. We check to see if it's less than 20. And then the increment is number plus equals 1. Right? So then we could say, OK, well, if the number is, when divided by 7, gives a result other than 0, then write the number. So this would write, well, it would start with 0. And the number 0, when divided by 7, does give a remainder of 0. Right? So it would skip writing the number. Then it would have 1. When number is 1, it does give a remainder when divided by 7. So it would write 1, 2, 3, 4, 5, 6. It would skip 7. It would write 8, 9, 10, 11, 12, 13, skip 14, and so on, up to 19, apparently. So this is a perfectly straightforward way to write this loop. Another common way that you see to write this loop would go like this. We would say, same header here. We would say the number is an integer. It's less than 20. We're going to increment it. Then we take the opposite, right? Before we said if number when divided by 7 does not give a remainder of 0. Here we have the opposite. When it does give a remainder of 0, continue the loop. Don't do anything after this. Just go back to the top and start over again, right? So these two things have the same effect, basically. And let's actually debug through those and take a look at how that works. I'll get rid of this code here. And we can just step right into that. All right, so we start off with number being 0. It is less than 20. Does it meet this condition? Well, no, it does not. Right? So we skip the consequence of the if. We go down to the bottom of the loop. We run the increment expression, the loop iterator. We check the condition. Now this time the condition of the if is met, so we run the consequence of the if, and so on. Right? And we'll just keep on doing this. Around and around we go, and so on. Right? Now if we step down to here, we'll see that we have a slightly different, though equivalent, control flow. Right? So we'll say, is the number when divided by 7 give a remainder of 0? It does. It's 0. Right? So then we'll continue. What does continue do? It goes directly to the iteration. There we go. Right? So we didn't do the rest of the loop, but we also didn't break out of it. Right? We went right back to the iteration. Now we check the condition. This time, the if statement is, the condition of the if is false. So we skip the consequence of the if. We go right onto the statement that follows it, write out the number, and so on. And we keep on doing that. So when the number is equal to 7, we'll enter the body of the if, the consequence. Then we'll hit the continue. The continue skips the rest of the loop, goes right back up to the iterator. So you want to use both break and continue judiciously, because essentially what break and continue both do is, well, break gives you a loop that has more than one exit condition. And that can be difficult to reason about. And continue is even a little bit more confusing than that, right? Because it says that there is stuff in the body of this loop that is not going to be executed every time through the loop, right? So why do you use these? Right? We've seen very simple examples here of different loops that have that either do use break and continue or don't use break and continue, and it seems like 6 of one and half a dozen of the other. You most commonly see break and continues used in loop bodies that are so complicated that it is difficult to express all of the logic that you want to express using a bunch of if statements, even if they're nested well. But if you are writing loop bodies that are that complicated, then you already have a problem, right? You should probably not be writing statements that are that hard to understand. All right. Try to simplify your loops. Try to not have too much complicated code. If you find that you're writing a lot of breaks and continues, you might want to take a step back and ask yourself, can I make this whole thing simpler? All right, so we've seen that we can have if statements that are inside other if statements. Well, we can also have loops that are inside other loops. So let's take a look at an example of that. All right, so we'll say let's just get rid of all this code here. Let's start fresh. All right, so I'm going to make what's called a nested loop here. A for loop is a statement, and the body of a loop is required to be a statement, so therefore the body of a loop can be another for statement. So I'm going to say for int number is equal to 1, number is less than or equal to 10, and then we'll increment it by 1. And then for the body of my loop, I'm going to say exactly the same thing. I'm going to say for number is equal to 1, number is less than or equal to 10, number plus equals 1. I'm going to console.writeLine out number. Well, we've got a red squiggly here, so something plainly is going wrong here. And if I hover over this thing, it says we've got a local variable. It's an integer. It's called number. A local or parameter named number cannot be declared in this scope because that name is used in an enclosing scope to define a local or parameter. Now, I want to start by, first of all, apologizing in a way. I did a lot of work when I was working on the C# compiler team to try to figure out some way to make this error message more clear. It used to be even less clear than it is now. I'm still not super happy with how it turned out, but if you parse it carefully, it does make sense, right? So a local or parameter named number, right? So we have a local here, right? The loop variable counts as a local variable, cannot be declared in this scope. Well, we don't say which scope it is, but remember that earlier I said that scope is a region of programming text in which a variable's name can be used to mean that variable. And I also said that C# has a rule that local variable scopes must not have multiple variables with the same name. Well, it turns out that a for loop defines its own scope. And so this variable declaration is within the scope of this for loop, and this for loop already has a variable named number. Right? So a local or parameter named number cannot be declared in this scope because that name is used in an enclosing scope to define a local or parameter. I'm also not super happy with the fact that it says local or parameter. The compiler knows that it's a local. It knows that two locals are in conflict here. It knows that neither of them are parameters. We'll talk about parameters in a later video and how to declare parameters and how they are like locals. But this error message, a little bit confusing. But basically, it's saying you can't do this. These two variables have to have different names. Right? Now, I want to digress briefly. You might have noticed previously in this video, I had multiple for loops that all used int number as their loop variable. And so how is that possible? Right? So here I have two for loops, two identical for loops, side by each, both of which have a local variable called number in them, and yet I haven't got any squiggly red underlines here. So what's going on? Well, basically what I just said before was the for loop defines its own scope, right? And everything within that scope must have unique names, right? There can be no more than one thing named number. But this scope and this scope do not overlap. And so there's a rule of C# that says if you have scopes that are beside each other, right, not one enclosing the other, then they are allowed to have name conflicts like this. And the reason for that is because it's simply very common to have two loops in the same method that differ slightly. You cut and paste one to the other, and it's a pain to try to come up with new variable names when they are not going to affect each other. Now, you notice if I try to do something here like console.writeLine number, whoops. IntelliSense got the better of me. Right? Then I get a red underline saying the name number does not exist in this current context. Right? Number is only valid inside this for loop because it's declared inside the for loop. You can't use it outside. Now I could, if I'd wanted to, say int number out here. Right? Now these both become errors because this enclosing scope that begins with the brace after the declaration of the method, this enclosing scope now contains a local variable named number, and now these scopes are overlapped by this outer scope. I could fix that by simply changing these into assignments instead of declarations. Right now we have only one variable named number, and we just keep on changing it throughout. Right? My recommendation, whenever I'm writing a for loop, I try to always have the loop variable, if it's a number, actually declared in here rather than being declared out here. But sometimes it is necessary to be able to examine the loop variable from outside the loop, in which case you can always declare it outside. All right, so that was just a little digression there. How do we actually nest loops so that it works? Well, what you have to do is you have to make sure that the loop variables don't conflict. So a very common way to do this is to say, OK, I'm going to have my outer loop loop over from 1 through 10, and the loop variable is going to be x. The inner loop is going to loop from 1 through 10. The loop variable is going to be y. And I'm actually going to write out what the different values are of x and y using this string interpolation syntax. You recall this is a feature of C#6. All right, let's see what happens if we just step through this. All right, so what's going to happen? Well, we always begin the loop by initializing the loop variable. Then we check to see if the condition is met. Then we execute the body. All right, what's the body? The body is this for statement. OK, how do we execute a for statement? Well, we begin by initializing the loop variable. So y becomes 1. We check the condition. It is less than or equal to 10. That's good. So then what do? We execute the body. So we write out, well, what are we going to write? We're going to write out 1, 1, because those are the values of x and y. All right, so what happens when we're done executing the body of the inner for statement? Well, you know what happens. We run the iterator of the inner for statement. Y now becomes 2. 2 is still smaller than or equal to 10. So what happens? We run the body again. We keep on doing that until the condition of the inner for statement is no longer met. So y is still smaller than or equal to 10. Now it's 10. It's still smaller than or equal to 10. Oh, but now it's 11. It's no longer smaller than or equal to 10. So what happens? We have completed running the body of the outer for statement now. So what happens? Its iterator runs. So we pop back up to there. Now you see how the control flow is getting more and more complicated as we start to nest these structures. And you can imagine how it would get even more complicated if we also had ifs in here, or if we had while loops, if we had multiple levels of loop nesting. All right, so now we increment x by 1. X is now 2. What's y? Well, y isn't in scope here, right? Y is only in scope inside this loop, and we're not in that loop anymore. So you'll notice it's even disappeared from the locals window over here. There's no y listed anymore. Is x smaller than or equal to 10? Yes, it is. It's 2. So what do? We enter the body of the loop. Right? Now, the last time we saw y, it was 11. Right? But we're going to enter the body of the loop. We start running the interior for statement all over again. Right? So y suddenly becomes, you can see in the locals window, it still thinks that it might be 11, but nope, now it's 1 again. Is that less than or equal to 10? Yes. So now we run the body of the loop. And now we have 2 and 1 for x and y. Keep on running that until y becomes 11 again, and so on. Right? So if we actually ran this program to this point, right, then you could see we would write out 1, 1, 1, 2, 1, 3, 4, 5, 6, 7, 8, 9, 10, then 2, 1, 3, 1, and so on, all the way up to 10, 10. All right. So that's nested loops. Nested loops can be tricky to reason about. So again, I try to use them sparingly. You might wonder what happens if you have a break or a continue inside a nested loop. And the answer is if we have a break or continue, they break or continue affecting only the innermost loop, only affecting the loop that the break or the continue is actually in. There's no easy way in C# to say, I wish to break out of the outer loop, or I wish to continue the outer loop. There are some kind of gross ways to do it, but we're not going to talk about them in this course. And basically, if you are writing loops that are that complicated, then you probably need to, again, take a step back and reconsider, have I actually structured this loop properly? Now, we saw previously that the loop condition did not have to be a comparison. It's almost always a comparison, right? Something like x is smaller than or equal to 10. But it can be any expression that's Boolean. Well, similarly, the loop of variable is almost always an integer for while, do, and for loops. But it doesn't have to be. So let's take a look at an example where it isn't, right? We can say, we can have a variable today that's equal to datetime.now.date. You'll recall this from a previous video, that datetime.now is a static property that returns you a date time representing the current date and time. That has a property called date, right? So this whole thing, .date, gives you today's date. We could say that next month is equal to today's date plus 1 month, right? And then we could say, well, for var date is equal to today. So this is our loop variable. It's a date time. So we could also have said date time in here. What's our condition? Well, date is smaller than or equal to this same date next month, right? Recall that we can compare two dates or times. The one that is farther in the future is larger than the one that is more in the past. And then we can say, oh, we need to change the value. We need to have an iterator here that changes the value of our loop variable. Well, how are we going to do that? Well, we'll take the current value of it, we'll add 1 day to it, and then we'll use that as the new value. And then we'll write out the date, right? And so if we do this, then you'll see that as we step through it, all right, so the date, I'm going to make this a little bit bigger so that we can see this thing. All right, this starts off as today, the 27th of February, 2015. Recall that dates that are not associated with any particular time, the time is set to midnight, right? What about next month, right? Well, that is 1 month from now, so March 27th, 2015 at midnight. And now we start running through the loop, right? So we say the loop variable is going to be date. It's going to be equal to whatever today's date is, right? So this variable is now the 27th of February, 2015. Is that smaller than March 27th? Yes, it is, right? So we enter the body of the loop. We write out the date. Now we check the, now we run the iterator. The iterator says, take date, add a day to it, assign that to the variable date, right? So it becomes the 28th of February, 2015. Is that less than this date next month? Yes, it is, right? It's less than the 27th of March. And so we just keep on doing this until eventually the condition is not met. And if we actually run this through and look at our output, then you'll see that we start on today's date, the 27th of February, and we run all the way through to the 27th of March. Summing up, the do loop is like the while loop, but it checks the condition after it runs the loop body, not before. The break statement executes a loop unconditionally, and it's a statement of the language. It can only occur inside certain constructs like loops. The continue skips the rest of the body, runs the iterator, and checks the condition, right? So it's like a break, except that it doesn't just leave the loop entirely. It sort of goes back to the beginning of the loop, runs the iterator, checks the condition. Use break and continue judiciously. Also, when you're nesting loops, nest loops judiciously. All of these things can create programs that become more and more difficult to understand as the control flows get more and more complicated. Always use distinct loop variables when you're nesting your loops. The compiler will not allow you to reuse variables unless the loops are beside each other instead of nested within each other. And loop variables don't have to be integers. They can be anything. Basically, a loop is just the structure of you declare a variable, you have some condition, you have something that changes the variables involved in the condition, and then there's a body, right? So all of those things can be anything you want. Very frequently, manipulations of integers, they don't have to be.